Hello everyone, my name is Jefferson Jacob and I'd like to present to you today our research entitled Enhancing the Durability of Concrete Exposed to Pig Manure Using Silica Fume and NANOSILICA. First of all, before diving into the research itself, I'd like to talk a little about what was our motivation to this work. It turns out that the cement industry is responsible for emitting 54 million tons of carbon dioxide a year. So, we might reduce the carbon footprint of concrete by minimizing construction defects, as well as making concrete last longer. Concrete is one of the most used materials when it comes to building pig houses. It can be found in solid and slatted floors, feeding troughs, storage manure tanks, treatment systems, and also silos. Pig houses provide concrete with a pretty aggressive environment, chlorides from the feed, and also organic acids such as acetic, propionic, isovaleric, and butyric acids present in the pig manure can combine with calcium hydroxide from concrete and produce very soluble components, causing the dissolution of the cement paste, exposure of the aggregates, and also corrosion of the rebars. Silica fume is an extremely fine powder, and it's a byproduct of the production of metallic silicon, and it can produce refinement of the pores. It can also increase the mechanical strength of concrete. The use of NANOSILICA in conjunction with silica fume has shown even better results. So, our study consisted of molding concrete specimens with different percentages of silica fume and an additive containing NANOSILICA. And then, we attacked concrete with acids present in pig manure and tested them for compressive strength and also measured water absorption and variation of mass along the experiment. As you can see on the screen, we have the mixed proportions we used in this study. 5 different mixes were produced. The first one, which we called reference, only with Portland cement, without any silica fume or NANOSILICA, and then 2 mixes with 5% and 10% of cement replacement with silica fume, and another 2 mixes with the same percentages of silica fume, however we used the NANOSILICA additive in them. In order to simulate the acid attack of concrete exposed to pig manure, a group called AC, or acid cycles, were immersed in a solution of organic acids. The cycle consisted of immersion of the samples in the acid solution for 7 days, and then the samples were removed from the solution, weighed, and left to dry in an oven for 24 hours. The dried samples were weighed and then immersed back in a renewed acid solution. 7 cycles were conducted this way. The second group was called dry wet cycles, and they were submitted to the same 7 cycles, but the solution, instead of acids, contained lime water, the liquid usually used to cure concrete. And here, as you can see on the screen, we have the results for compressive strength. So, as expected, the acid solution decreased the compressive strength of all concretes, and the concrete with 10% of silica fume showed the best results concerning compressive strength. And as for the results of variation of mass, the samples with 5% of silica fume showed the lowest mass loss, indicating then that it can have better resistance to the acids. Similar results could be observed here for water absorption, but here the samples with 10% of silica fume and NANOSILICA showed the lowest water absorption, what might indicate better resistance to the acids as well. We also took pictures of the samples along with the experiment. So in A, you can see the samples before the acid attack where they are still smooth. And in B, you have already the aggregates being exposed where you can see the dissolution of the paste. And the same for figure C, where we took a picture of the in cycle 7. And then I'd like to finish this presentation with some of the conclusions that we could draw from this study. So the acid attack promoted the leaching of the hydrated cement products, leading concrete to present severe superficial wear in exposed aggregates. The use of silica fume and NANOSILICA in all cases produced enhancement in concrete properties, elevating the compressive strength, reducing the mass loss, and water absorption. Thank you for your time.